Good evening. Last talk of the second day, which is exhausting for attendees, and I'm very glad you made it here. So thanks for your time tonight. My name's Markus. I'm a developer advocate for Lightbend, and I have to admit, for most parts of my professional career, I actually worked in Java EE and enterprise technologies. I've been designing big systems as principal architect. I've been doing a lot of things around classical monolithic applications. And I was always curious to share what I learned on the way, so that brought me to a couple of conferences all over the place. Because I was still not completely occupied, I also started my own conference, so this is just a little spoiler. If you guys want to go on roller coasters during a conference, I can definitely recommend you to look into JavaLand, which is happening in Germany. Let's talk about Java EE and Jakarta EE for a minute. Java EE is kind of considered legacy, and I've heard so many people talking about it being dead because there hasn't been a lot of movement lately. In particular, since Oracle kind of decided to give it away, right? I mean, they were honest enough and brave enough to donate it to the Eclipse Foundation. And so after a very, very dry couple of years where not a lot happened in the specifications, we are hopefully seeing some movement soon under a new brand name, which is Jakarta EE. That has all kinds of implications. I'm pretty sure you've read the news over the last couple of days, so they donated successfully, included all the specifications, including the TCKs, so people can actually start to contribute again. The only thing they did not get is actually a trademark usage right for Java. That has a couple of implications, just thinking about package names or specification names that we all loved and knew over the past couple of years. For example, Java Message Service is probably going to be renamed very soonish. Jakarta EE was kind of on the horizon for the longest time already. And the Eclipse Foundation did a survey where they try to figure out what the future direction for Jakarta EE in general should actually be. So top 3 mentions out of this 1,800 developer survey. Somebody wants to do, people want to do microservice. They want to run on infrastructures, most likely Kubernetes, which are stateless, easy to scale. They definitely want to go more into the cloud native direction. There's also been mentions of Node.js. I think microservice is kind of the topic of all the answers here. People want to be more agile, want to get away from these kind of monolithic applications. I have to admit, I was just reminded about an application I was working on that ran on a famous application server from a company with a blue logo and 3 letters. And this thing actually took 14 minutes to start the complete application. So I can definitely understand that people want to go away from that again. Reasons people have chosen Java EE. I'll look into that a little bit later. So just as an update, this was presented, I think last week by the Eclipse Foundation, a little overview, high-level roadmap for Jakarta EE. After most of the problems seems to be sorted out, I guess we can look forward to Jakarta EE 8, which will pretty much be a Java EE 8 version that tests against the TCKs, and Jakarta EE 9 will finally start to kick off innovation again, hopefully. A little mention about the changes in process. I'm not really sure, has anybody contributed to the Java EE specifications or within the JCP in the past? A lot of people. So I actually had the pleasure to be part of Java EE 7 expert group and been kind of intimately familiar with the Java community process. So I've always executed my rights to vote. And this is something that significantly changed. And I think to the better. Instead of having these old approaches, waterfall-like, to start specifying something and follow with the implementation afterward, the new Jakarta EE will be a lot more, let me say it, agile, or should I say flexible. So we'll have a code-first approach. It will not be an exclusive specification lead for the individual specifications, but it will be a collaborative development. Instead of having closed source TCKs, so nobody can actually look into what's going on and what's been specified, they'll be open sourced and available. And I guess the complete model, which is an acronym for EFSP, is under the Eclipse Foundation, will be a lot more open and a lot easier. So why is Java EE even a thing anymore? Like, are people still doing Java EE? The advantages are pretty obvious to me. So 10 million plus developers in the world, 90% of Fortune 500s are running these kind of systems as of today. You could easily get people onto these projects. The knowledge about Java EE technologies is tremendously broad, available, and widespread. Like even in university, people know how to implement a servlet, and you can literally grab somebody from the street and have them integrated into that development team, right? And honestly, I've seen that happening. So there are plenty of good reasons, but are Java EE applications even a thing anymore as of today? I was curious myself, and I couldn't figure that out ultimately. So the best thing to get a knowledgeable answer is to actually run a Twitter poll, right? So this is what I did yesterday night. This is actually not the final result. I was too lazy to copy that over, but you can see the trend and you can definitely see the winner here. So obviously our solution space for technology implementations for application development has grown tremendously over the last couple of years. Instead of big companies insisting on specific stacks by certain vendors, there's a lot more flexibility. And I do believe that not mainly the stagnant Java EE specification is a reason for that, but this movement has been initiated and made available to us by containers and orchestration solutions, right? So for operational people, it is more important that they have a standard that they can actually put into production, which has been tar files or WAR files before, right? And as of today, it doesn't actually matter what we put into these containers and distribute them. That makes our lives a lot easier. And I guess it also makes it a lot easier for the companies trying to define their architectural blueprint. So obviously, Java EE is not the biggest main driver anymore. And I've made an assumption here that many people complained about. I put monolith in brackets. Of course, there are other alternative architecture styles that you could do with Java EE, just to state that out clearly. My intention was actually to put more broader and bigger buckets here so people could easily identify what I'm thinking about. This is a Gartner quote. I always wanted to have a Gartner quote on one of my slides, so thanks for that. Why is this old style 3-tier architecture actually dead? I think the reason is that many people have more access to devices and are connected to the internet. I think as of 2018, it's like 40 billion people connected to the internet in some way. Our data processing requirements changed significantly. While we, in the past, ran batch jobs over the weekend, put something into databases, analyzed that somehow, and had like an online system working on top of that, today the data is coming in even faster than those kind of batch runs could definitely process them. But on the other hand, monoliths have had absolutely advantages. I mean, they told us that consistency is something that we can definitely take for granted. It was a single database world. Like everything was put in one database. There was no question. The truth sits at rest in that one database. We had the illusion of some kind of consistent state in this database because we had something that were called transactions. Some very brave people actually worked with two-phase commit protocols and try to make these transactions even more capable. Data was a static thing back in these days. Funny enough, it always waited for us, for our applications to work on it. Failure is handled. That is one of my favorite features, actually. So an application server, especially a Java EE application server, is a complicated thing, right? And if we just think about EJBs, for example, they had a life cycle. They were passivated, they were activated. They probably failed at some point in their lifetime. And most of these failures were actually handled by the application servers. We never had to check if something is alive, if we actually referenced it in our code, right? So there has been nothing that really made us aware about problems like partial updates to the database. We just got a transaction rolled back exception that we had to handle in some way, right? So consistency was completely enforced. And concurrency, of course, was handled. Not in a great way. Scaling was a little challenging with these application servers, but it definitely was handled, so positive plus. And we had no uncommitted reads. So there's a little animation in here. Our transactions coming in, changing some data, second transaction is coming in, and we end up having a consistent state in our database, right? So here's the bad news. When we start thinking about different application approaches, when we start thinking about distributed systems, smaller, more lightweight servers underneath, or even no servers at all anymore, this consistent view of our world breaks down completely. Distributed applications consist of many, many databases and data sources. They are in no way at rest at any point. The state is consistently changing. There is everything possible in this kind of distributed world. Different services have another completely different idea of a consistent state. There might actually be user data that one service has successfully read from a database, and another service is using an old copy of that or a cached copy of that. I think Dean Wempler, who's one of our VPs of engineering, he coined the term data in motion. And I think what this beautifully expresses is the fact that data is just not consistently sitting somewhere anymore in a database, but it's consistently transitioning through the system from one service to the other. And it's no longer static. So it's getting harder and harder to create a consistent snapshot of such a distributed system. All the beloved application server features that we grew up with are gone, ultimately. Like, there is no failure handling service anymore. There is no consistent microservices architecture that has a failure handling service layered on top, right? So it is absolutely possible that we see something like partial updates, that something in our database is no longer consistent. We have no external enforcement for these kinds of operations that transactions made our life so easy with. That also means concurrency is inherent in this system. You can't really decide in which orders some things are executed. And some operations actually might take time to propagate through the system. If we take a look at one of these fancy microservices architectures, and this is obviously a simple overview of random number of services, we can make a little walkthrough, right? So let's assume there's a call to service A and a call to service F. REST endpoints, whatever you can imagine. So these services fan out, call downstream into other services, and call back and gather their data to actually respond to the request at some point. And this is getting a fancy little get-together party for all the microservices, right? And guess what happens? Service G blows up. Maybe a classic out-of-memory exception because it's a Java service, you know, I know, whatever. So who's brave enough to actually tell me in which state these services are in? Like, did they complete? Did they return a failure? Is the transaction, is the request lost? Whatever happened in this world, it got way more complicated than it ever was before. And what about the other services if actually service A blows up too? So we have two more in question, which kind of leaves us in a very well-defined inconsistent state for the whole architecture. So basically, what I'm telling you is what worked for monolithic applications doesn't really work in these distributed / microservices architectures anymore. But what was that? Like, completely speaking, it was a simple CRUD mechanism, something that we could read, update, delete in one database. It depends on the single state of the database that we no longer have. Transactions, we scratched that, right? Absolutely. REST as an external-facing architecture to access resources is also not well suited for these kind of systems because it depends on consistency being handled in the database. What we need for distributed applications is a completely separate thing. You've heard that before. Distributed applications should be designed events first. Events in the way that they convey facts, that they convey change events, right? They remain true no matter what happens in the system and can be recorded in events logs. At least once messaging ensures that messages are being propagated throughout the system. And last but not least, a stream-centric view on our data. The data becomes the events in the systems and is in motion and no longer in the database, right? So some may be at rest when we're done with that, but yeah, there's actually no single state at any point in time anymore. The system keeps converging and keeps moving its data from A to B. So if we now look at the different approaches from monolith to microservice architectures, the question that comes up is pretty easy. How can Jakarta EE support that? Or should Jakarta EE actually support that in any way? And we, Enlightenment, believe strongly that there is definitely a way to enable existing applications to take a first step into these stream-centric view into a distributed systems world. And the most likely point that is suitable for integrating with these existing systems are streams. So if we are looking at streams, we can think about a stream as a pipe between two individual services. Service A emits events through this pipe, and if service B crashes, the events are still available, and as soon as service A forgets about all the sent events instantly, as soon as it's done, and as soon as service B comes back up on, he can start processing these events, right? So in the way of modeling a system that is following this events-driven approach, we can start taking eventual consistency for granted, which is something that is very different from a consistent state in a single database. So far, so good. But how can we integrate that in a reasonable way? And you might actually have heard about streams before, and you might have seen the Reactive Streams presentation, I think it was yesterday. Reactive Streams is actually a good specification to start with, right? So Reactive Streams is the de facto standard formed by many, many companies to allow streaming between different technologies. It is not meant for end users. It's kind of an SPI. So even if it is available in the beginning JDK9 as the Flow API, it's definitely not meant to be used by end users. It's meant to be implemented by Reactive Streams libraries. One thing that you'll definitely come across is the term back pressure. That basically means flow control between services. So instead of just shoveling data through a pipe and having the downstream service consumed from literally a fire hose, we actually let the downstream service tell the producer how many packages he can actually consume. This is kind of managing the back pressure and will help in systems where services have different capabilities in terms of processing messages per second, or need to be more aware of what's coming in terms of masses of data. There are a couple of certified implementations. The TCK is publicly available, and it actually needs a high-level API, as I said, to manipulate streams. There's a good example, which is RxJava, or you could also use Akka streams. Little side note, whenever you see such a nice little URL on the very bottom of a page, I consider that homework. And you have no idea how that story is, but I have 2 girls and they go to school and they hate homework, but I hate it even more since they have to do it. So that's why I decided that I can give you a little homework if you're interested downloading the slides afterward and digging a little bit deeper into these topics. But aren't there APIs for this? Like, don't we have something in Jakarta EE and in Java EE already? Isn't there a bunch? That looks familiar, doesn't it? And they can all kind of handle streams to a certain extent. So here's my most favorite question. Can I pipe an input stream into an output stream? Yes, no? No, you can't, right? I mean, you have to actually write the input, read the input stream byte by byte and pass it over into the output stream. Pretty much the same is true for every single of these specifications. And unfortunately, that doesn't make our life easier in Jakarta EE because there's so much. I'm trying to not say legacy because I definitely honor the critics by many people that are saying that legacy is not necessarily a bad thing, but I'm trying to envision a new thing, I could call it, but you know where I'm getting at, right? So how could that work? I think reactive streams is a good example. This is another little example that is part of the slide deck with Akka streams. So Kafka is actually emitting stuff and it gets passed to a WebSocket handler. This looks pretty straightforward, right? So messages go down the one way and the communication about resource usage and back pressure goes down the other way. So we thought about how we could help with that problem. Obviously, Akka Stream solves a lot of these problems already, and you can use it as of today. So how can we enable Jakarta EE to profit from that? And we thought about it, given the transition process from Oracle to the Eclipse Foundation. Jakarta EE itself doesn't seem like a good playground to start some new initiatives right now for such a small company as we are. So we decided to engage with the Microprofile project, which is, many people call it an incubating ground for Jakarta EE. Many people call it the microservices base runtime on like best of breed Java EE technologies. I'll let you decide what the definition is. The project has another one up on their website. Once for sure, Lightband decided to contribute, and we started working with the Microprofile project on something that is more high level, that can be compared to the to Akka streams in a way that integrates with Java EE technologies. And the name for that specification is actually Reactive Streams Operators. It is a specification set of operators for reactive streams manipulation. The standard stuff, like what you would have imagined, right? James Roper, who was mainly driving this project on behalf of Lightband, took the best of all the available worlds. There are a couple of implementations out there, as I mentioned, and I think he really made a good choice at that point. It also uses the Flow API, and I think in the meantime, there's a full stable version 1.0 released, so I probably need to update these slides. You can help shape the specification. Just go to the GitHub repository link down here. It is not necessarily something that has to resist in the platform specification on top of a JDK. We were ultimately hoping that on the long term it could be included in the JDK. If that's going to happen, who knows right now. There are actually 3 implementations under active development right now. One is a zero dependencies implementation like green grass roots. The other one is based on Vertex, and there's another implementation based on Akka streams. What do we do if we have the basis covered with the technology that could be used across all other specifications to enable Java EE further? Actually, it would be time to implement the first specification himself, right? So the plan is, and I think the plan continues, to implement a new specification that is connecting messaging resources in some way. It sounds kind of familiar to JMS. The problem with JMS is it does not understand back pressure. It does not comply to reactive streams. So the idea is to have something that is able to connect all these resources in a way that is compliant with the reactive stream specification. It obviously is based on the streams operator specification. I should have talked to him about naming. It seems a little confusing from time to time. Annotation-based development and definition of message subscribers and publishers sounds pretty easy and actually is. I do have not looked at the API this week, but I do believe it's constantly evolving, and the TCK is obviously also part of the open source project. There are 2 implementations right now that are simultaneously developed. One from Red Hat, Clement Escoffier is driving these efforts, and on our side it's still James Roper driving that further. Inclusion in microprofile 2.2 did not work out, obviously. We are still working on better solutions for that. If you wanna look at the example application that is built on top of these 2 concepts, you can look at James' repository. Early warning, this is definitely something that is not usable in any form. Like it's not beta, it's not alpha, it's just not usable. It's more like a POC kind of status. The typical eBay clone that you would have expected, it's based on Lagom, which is one of our open source frameworks for microservices on the JVM. And yeah, it's basically a port from an existing demo that we also use together with Lagom. And it is meant to be played around with. So fork and star and do whatever you want to do. Summary, I love the consistency, guarantees, and the development experience that came with monolithic application servers. And I mean that in the best possible sense, definitely. They gave us so many things as developers that we don't really had to care for. It was tremendous. They also came with drawbacks, just mentioning those 14 minutes deployment times and startup times, and it was still time to drink a coffee in between, right? So there have been good parts of it. The new approaches, new architecture approaches, call them distributed applications in general or microservices architectures, definitely need a different approach to application designs. And you can find something in the microprofile. So sharp reminder, even if we're all technical, don't underestimate all the other challenges. So there is no one technology that you can use going forward. And maybe this is a good warning. I have to admit that the Twitter poll I showed you earlier, there were a couple of really harsh critiques from people who were not in line with my definition, and they were pretty blunt online, which I can totally tolerate. I'm German, so that's not a big deal for me. But you definitely also need to remember there is a cultural shift in being in the distributed application space. There's so much more that you need to look for. There are so many more technologies in general. The solution space will no longer be as small, comfortable, and narrow that it was 10 years ago, where we all just had Java EE application servers, and the first people were actually fighting for Node.js applications. This is just not happening again. So you will always have to make hard choices. And there are alternatives for all kinds of architectures out there. And I can just strongly encourage you to not only look at the technology, but also about the underlying operating systems, the runtime environments, the orchestration system, your processes. Guess what? Agility is often mentioned when it comes to these kind of service-driven approaches. We're always confronted with the term two-pizza team, right? So it's something that does not comply with any old development or project management methodologies. Just thinking waterfall or even XP kind of approaches, right? So there will be a lot of lessons learned that have nothing to do with technology. What you can do, this is where the fun starts, because I'm actually always asking everybody in my talks to actively contribute. First and foremost, to microprofile. If Java EE and the related technologies are near to your heart, dear to what you do every day, please take the opportunity to engage in the microprofile project. Learn about reactive streams, because stream processing, event processing is definitely going to be the future from here on, in no matter what constellations and architectures we'll see. And this is a short link to the GitHub demo repo. If that is not enough, and if you want to learn a little bit more, our CTO, Jonas Bonner, wrote a free O'Reilly ebook. I'm not sure, it has 85 pages. It's a PDF version, free to download. Just go there, grab it, read it on the flight, or not on the drive back. Don't read and drive. Okay, and that was like, it is a little dated, but it has a conceptual approach that is completely valid as of today. He also publishes a lot of materials, so you'll just dig his name and his latest articles. There's a lot of interesting stuff coming out of him. But when I saw this book, I was kind of intimidated that I was not writing a book. So I decided, if he's writing about architecture, I'm writing about development. And yay, I got my own book. This is walking you through the very beginnings of microservice-based application designed and developed in Lagom, which is also an Apache licensed open source framework. And in my ancient past, this kind of came to light. As you can imagine, the company that I worked for back in the days. I still like this book. And it is older, but it is a very good tool for you to either convince your boss to move to a distributed architecture, to microservices in particular, or argue against it. It gives you lessons learned for both. And last year, November, I had the pleasure to be in a little panel together with very valued, good friends, and we talked a little bit about Jakarta EE, about the whole play together with microprofile, about the future, how that could look like. I can only I cannot stress enough how thankful we should be for everything Oracle contributed to the Eclipse Foundation under the Java EE/Jakarta EE label. But it's also absolutely important to realize that there's a lot more to do as of today to make this slightly outdated, let's say legacy stack, fit for the next challenges that are coming with a lot more connected data, devices, and everything that's coming at us. Thank you for your time. I'm not sure if we have more questions. If somebody put something in, I'm happy to discuss. I'll be around a little longer. I didn't want to be the last person standing in between you and your beers. Microphones coming, questions coming. Yay.
We don't have any questions
Cool.
related to the website. I don't know if there is any question. If you want to ask something, please raise your hand.
You can definitely reach me on Twitter via MyFear. DMs
yes,
are open.
I think we have a question over there.
Can you hear me? Okay. Thank you for your presentation. It was very interesting. And probably maybe a typical question, yeah? For example, in the past I was a fan of enterprise tech, and usually people discuss like use enterprise tech or Spring Stack or both, and so on. And when Oracle decided to forget about enterprise tech, I suppose that it was the end for this stuff. But I see you try to working on it. And the question is, what is the main motivation to continue to work? I understand alternatives is okay, but probably now usually people contribute to Spring Stack. Yeah, like if you have even your ideas, probably, like I don't know. For me, it's more interesting why you decided to continue to work on it. Thank you.
Good question. I do believe that many people underestimate the influence that the Java EE APIs have on stuff like Spring in general. I also do appreciate that many people decide to go with Spring Boot as the first and main implementation technology because it is so close to what Java EE has to offer. It conserves knowledge. Like, we don't have to think a lot about things that are uncomfortable, like eventual consistency and failure handling. There's a lot more support in Spring. What I do believe, and this is more a personal statement than it is an official company statement, but Java EE, call it legacy, be mean to it as a technology, will be there for the foreseeable future. In many enterprises, we will have to maintain it, we will have to find ways to improve it, and we will have to find ways to support better business models. And just putting a completely separate stack next to it is probably not always the ideal solution. Just using standard interfaces might also be too slow from times to times. Do we really want to go back into the database and work with PL SQL kind of stored procedures to get everything out of existing systems? I do personally appreciate a wide range of options that I have to solve certain problems. And to quote one of the most famous things that an architect could say, it depends, like your technology will depend. I still love Java EE. As I said, it will be around for longer. So having an integration point that has opportunities moving forward is exactly the right thing to do. Does that answer your question? Thanks.
Any other question? Okay. Well,
thank you all for coming.
Big applause to Markus,
pleasure
please.
to be here. Have a safe trip home.